So we're going to go through this resolving forces question. So this is a worded question, there's no diagram provided, so we're going to work through it slowly and just read the main information given to us. So we've got a particle with mass m. It's a smooth slope, so we know that we don't need to worry about friction. There's a 30-degree angle and a force of 5g newtons acting at an angle of 60 degrees to the slope. This is causing the particle to accelerate up the slope at 0.5 meters per second squared. Show that the mass is given by 5g over 1 plus g kilograms. So first thing we want to do is just draw the diagram out. So we know obviously we have a slope, so let's draw that here. And then we're going to label what we know about the slope here. So we know that we have a particle, so usually we just draw this as a box, and then we've got mg. Now we don't know the actual mass, so we're just going to leave it as mg. We know that there is a reaction force always which is perpendicular to the floor, or in this case the slope, and it's accelerating up the slope. So we normally show acceleration with a double-headed arrow like this, and we can just say acceleration equals 0.5 meters per second squared. Then we also know that we have a 5g Newton force acting at an angle of 60 degrees to the slope. Well, let's actually label this 30 degree first. So we know that's 30 degrees. And then we've got something that's 60 degrees to the slope. Well, if this is the slope here, or parallel to it, then a 60-degree angle is going to look something like this, just like an arrow there. And then we can essentially say that if this is the slope, that angle there is going to be 60 degrees. The other way to show this is you can show the force kind of going out of the object as well. So that's just another way, and then this would be 60 degrees to the slope. I personally prefer doing it this way, but just for the sake of this diagram, we're just going to keep it behind the object, the particle. And then that's our diagram. So what we want to do here is now just resolve this as much as possible into different components. So we've got here, we know that's going to be a 30-degree angle. So that's going to be mg cos 30. And then if we resolve that mg in the other direction, this is going to be mg sine 30. So that's been resolved. And then we want to resolve this force here, which I'm just going to make it orange just to make it clearer. So this force here, when we resolve that, essentially it's the same as resolving it into the two purple components. So it's going to be up the slope, but also some component of it will be down the slope. So just to reiterate from here, we've been told that there's a 5g, that force is 5g. So I'm just going to write 5g. And then the two purple components are, well, let's look at what the angle is here. So we know that this angle given to us is 60 degrees. So this will be 5g cos 60. And this, the purple component going down here will be 5g sine 60. So everything that is going parallel to the slope and everything that is perpendicular to the slope, we're going to separate these two out and then do each one, simplify it. So resolving up the slope. Well, the forces going up are the 5g cos 60, and the forces going down are mg sine 30. So we can say, because this is accelerating, we're going to use F equals ma. Now remember, along the slope we're going to have 5g cos 60 minus, and then we're going to do the mg sine 30. So that's force is equal to mass. Now we don't know what mass is, so we're just going to call it m, times acceleration. Acceleration is given to us as 0.5 meters a second. So we're just going to call that 0.5. And then we can tidy this up. Cos 60 and sine 30 are nice numbers. So when you put this in a calculator, or you might already remember it, cos 60 is just a half. So 5 times g times cos 60 is just 5 times a half times g. So it's 5 over 2g. And then sine 30 is going to give you a half as well. So that's take away mg, or a half mg, is equal to a half m, or m over 2. Now we want to essentially show that the mass is given by this. So if we rearrange this, one way to start this off is just multiply everything by 2. So let's do that. So I'm going to multiply this side by 2. We're going to multiply this side by 2. So that's going to give us 5g minus mg equals m. And we want to make m the subject, so let's add mg to both sides. So that's going to give us 5g equals m plus mg. We're going to factorize m out, so this is m times 1 plus g. That's 5g is equal to, and then finally just tidy this up by dividing by 1 plus g. So just do that in a different color. So divide by 1 plus g, divide by 1 plus g. So we now have 5g over 1 plus g is equal to m, as required by the question. So key things here to note are this this angle of 60 degrees can be quite tricky to visualize when you are drawing the slope here. So some people will prefer to draw the 60-degree angle going into the object. So I think it's much easier to draw it going out. It doesn't matter. So you can, for example, show a 5 Newton meter pushing force as it's the same as a 5 Newton meter pulling force for our method and for our explanation and for this type of situation. So that's your answer to this question here, which is also on the slides. Smash the like button, hit subscribe.